Okay, so welcome to Introduction to Inequalities. And if you guys participate, then I guess we can do a quizzes because Blue Kid wasn't working. So the topics is AM, GM, and HM, and also Cauchy-Schwarz inequality. So first I'll be talking about AM, GM, and HM. So here are the definitions. AM-GM stands for the arithmetic mean and geometric mean inequality. So I think when everyone thinks about mean or average, they think of arithmetic mean, which is when we just add all of the numbers and then divide by the numbers of numbers there are. And then for geometric mean, it's when instead of adding everything up and dividing, we multiply all the numbers and then do a square root depending on the number of numbers. So for example, if we wanted to find the geometric mean of 2 and 8, we would just multiply both of them to get 16. And then since there are two numbers, we would just do a square root. So that's 4. So then this inequality states that for non-negative numbers, x1, x2, x3, and so on, the arithmetic mean is always more than or equal to the geometric mean. And equality is achieved when x1, x2, and x3, and so on are all equal to each other. So basically, if all the numbers are the same, then their arithmetic mean and geometric mean will be the same. And this inequality is useful for finding minimums and maximums of algebraic expressions and finding proofs. So I'll just show you guys a simple proof for two terms. So yeah, so since they're both non-negative real numbers, we can square both sides. And we can expand this to get and we multiply by 4, we'll get this. And then once we subtract 4x1, x2 over here, we can factor out what was on the left side and we'll get this. And we know that this is always true because since both of them are real numbers, their difference will be also a real number. And basically anything real, when you square it, will always be more than or equal to 0. So therefore, two terms AM and GM will always be true for this. And then, so a note is the general AM-GM inequality for more than two terms requires calculus. So I'm not going to teach that. Okay. So I'll let you guys try out a problem now. It's pretty easy once you guys get the hang of it. So what's the minimum value of x plus 1 over x? And I also included the formula over here if you need it. I have one answer, so I'll just wait for, I guess, another minute. Just use x and 1 over x as your two terms for AMGM. Okay, I'll just explain this. So it's actually not that hard once you understand how to do it. So we're just going to use x and 1 over x as the two terms. So if we plug into the formula, the arithmetic mean is just those two divided by 2. And then according to AMGM, this is going to be always more than or equal to the square root. As these are two terms, that's why we have this. It's going to be the square root of x times 1 over x. And then we see that these two cancel out. So once we do that, it would be this 1. So this means that x plus 1 over x divided by 2 is more than equal to 1. So we just multiply it by 2. That means that x plus 1 over x is always more than or equal to 2. So therefore, this is the minimum value. And I guess if you just plug it in for something that's x, when x is equal to 1, then that's how we would get this. So I'll move on to the next part. Okay, so you guys just need to try a small twist on this. So it's the same concept, just plug in to the formula again. I'll just give you guys a hint. So we have 4 terms in here. So if you just plug it into the formula, I guess, and turn this into a 4, since there's 4 terms, and also put a 4 there, you should get an answer. Okay, I'm just going to explain this right now. So just going to copy down these 4 terms. And then there are 4 terms, so you divide by that. And as you can see, this will just cancel out and it'll also be equal to 1. So we have this x squared plus x plus 1 over x plus 1 over x squared is going to be more than 4 times the 4th root of 1, which is just equal to 1. So the answer is 4. And if you also put x as 1, then you still get the minimum value. So yeah. So I'll show you guys a proof of a problem, and then you guys can try out this one. It's a little more challenging, but you just have to rearrange it a little bit, and you should get the answer with ANGM. So now I'll be proving this. So if we just focus on this first part, using AMGM, we know that this will always be more than or equal to the square root of AB. So that means that A plus B is always more than or equal to 2 root AB. So we kind of have a new thing that we can use. So now we just do the same thing for both of these. And we should get these 3 equations. Okay. So now we have our basically original 3 terms, and they're always more than or equal to these new terms. So now we can plug it in, and let me do it down here. So A plus B times B plus C times A plus C is going to be more than or equal to 2 root AB times 2 root BC times 2 root AC. And then when we simplify this, we should get that this is equal to 8ABC. So therefore, this expression is true. Okay. You guys can send anything in the chat if you have questions. So I'll just erase all this now. And you guys can try this problem down here. This one is more challenging than the other ones, so I'll give you guys a hint. If we just focus on this first term, you can rearrange this to get this. And then if you focus on this part and just plug it into the formula, you should get an expression. And then when you multiply it, you should get a minimum value. I'll give you guys another minute. I'll explain this one. Okay. So we're gonna rearrange this to be b plus a over 2b, and c plus d plus b over 2c, and a plus c over 2a. And then if we just focus on the numerators, like for example, the first one, using AMGM, we should get that this divided by 3, because we can count the two b's as two separate terms. It's going to be more than this. Just multiply them. So if we plug in all of these into the numerators, then this original expression is going to be more than or equal to b squared a 3 2b minus okay. And then we can simplify this to get, because we have basically b squared here and then a b here. So it's going to be all of them multiplied together to get this. Oh, I forgot one step. We have to multiply this to get here. So we'll add in basically a 3 in front of all of them. So that means that we'll have 3 to the third times this. So we should get 27 ABC over 8 ABC. And therefore, the minimum value is 27 over 8. So this is the answer. So yeah, this one is a little bit more challenging, but you just have to rearrange them to get it to where you can have some different terms with a coefficient of 1, and then the formula will just make it a lot easier. Okay, so now I'll explain HM. Okay, so what is HM? This stands for harmonic mean. So for non-negative numbers, x1, x2, x3, etc., the harmonic mean is n, which is the number of terms there are, over basically the reciprocals of all the terms. So now you guys can make a guess which one is correct. Two of them you should be able to rule out based on what I've been explaining the last 30 minutes. Okay, so I'm very glad that most of you guys didn't do C or D. And then both of these seem like reasonable answers, but the correct one is B. So unlike A and GM, there's a way to explain, like prove this without calculus. Okay. So let's prove that the geometric mean is more than or equal to the harmonic mean. So I'm just going to set this up real quick. Okay, so the way I'm going to do it is technically backwards, but basically if you were to write this out, then you would basically do the proof I'm going to show you backwards. So a little bit complicated, but it'll be fine. So now we're going to multiply the whole equation by this and then divide by this. So basically we're just switching these two around. So you should get all of the reciprocals. It's going to be more than or equal to n over this. Okay, and now we just divide by n. So I am running out of space, but that's okay. divided by n, and you're basically left with the reciprocal of the geometric mean. Okay, so let's look at just this left side for 1 second. So if we just treat all of these reciprocals, each of them, as a term in AMGM, we should get that all of them add together, divided by n, because there are n terms, is going to be more than or equal to 1 over this, because it's basically just all of these reciprocals multiplied by each other and then put under root to the nth power. And if we simplify the right side, we'll get that obviously 1 put under any root will just be 1. And then you'll get this. And this denominator should look similar or familiar because it is what we were trying to prove all along. So that is why GM is more than HM, which would explain, which would help you eliminate these two, because now I know that GM is more than or equal to HM and not the other way around. So let's go to the Cauchy-Schwarz. I'll be honest, I had to Google how to pronounce this. So I think it's Cauchy-Schwarz. So this formula looks kind of complicated, but once you get a hang of it, it's actually really useful. So for two sets of real numbers, just any set of real numbers, the Cauchy-Schwarz inequality states that basically each of the term squared, all of them have to be squared, and you do the same thing to the second set, it'll be more than or equal to all of them multiplied, and then don't forget the square root. So I think it's easier if you guys try to put this into a problem. So you guys can try this problem. And if you can't use Cauchy-Schwarz, you can also use AMGM to prove this. Okay. I'll explain both ways so you guys can see how both of them work. So I'll go with AMGM first, and then I'll go to Cauchy-Schwarz. So A plus B plus C divided by 3 is more than equal to this. Okay, so now just move the 3 over, and we have A plus B plus C is always more than or equal to 3, and then the cube root of this. And then we'll do the same thing to these and let them be the terms. So one over A plus one over B plus one over C is always more than or equal to 3 times this. So now when we use these two equations and multiply them, that means that this original expression is always more than or equal to basically these two multiplied. So you should get 9 times the cube of ABC over ABC. And this, to, this is just equal to 9 times 1, which is equal to 9. So that's how you use AMGN to solve it. Okay. Now let's do Cauchy-Schwarz. So it's a little bit harder to see, but if we let basically in this problem, if we let the terms be root of A, root B, and root C, and for the second one, let the root of 1 over A, root of 1 over B, and root of 1 over C. So if we use these as our sets of real numbers, then we can just plug it directly into this, basically. So I know this looks really repetitive, but just going to include all the steps. And then when you simplify this, this would pretty much just speed this. And then according to the Cauchy-Schwarz, we can do this. So it would be more than or equal to the square root of A over A, because we multiply root A and root of 1 over A. So that would get this. And then we have these two, and root of C over C squared. And then, as you can see, they can all cancel out. So it would just be 1 plus 1 plus 1 on the inside. So that'd be 3 squared, which is also 9. So for this problem, you can use either way to solve it. Okay. So now I'm just going to do some mixed problems, and you can use AND, GM, HM, or Cauchy-Schwarz for all of them. So I'll give you guys a few minutes to do these first two problems. Do what you must with the two hints, and I'll give you guys a few minutes. Okay, good. I'm seeing some more answers, so that's good. Okay, so I'll explain them. Okay. So for the first one, we can use HM, yeah, and HM for this. So first, let's do it to where we have three terms. And then for AMGM, we will divide them by 3 because we're going to pretend that each of these is a term. So by HM, we'll have 3 over 1 over P plus C plus 1 over C plus A plus 1 over A plus B. Okay. So now we can move this over and we will have it where we'll move this one over to the side. And then we'll move this whole thing over to the denominator technically. So we should have these two terms. And then we can add these up. So we'll have 2 times A plus B plus C. Okay. And now we're going to just multiply this over. And this will be more than or equal to 9 over 2, since we still have this 2 over here. Okay. I will move this over. And when we expand, we can see that we'll have this. Because we have this B plus C, and the denominator is B plus C. Yeah. Okay. So now, as you can see, we already have these 3 terms. So we just have to subtract these 3 ones. So our original equation is more than equal to 9 over 2 minus 3, which is 3 over 2. So the answer is 3/2. So that's the first problem. Okay. Now we'll go on to the second one. So find the smallest value of this, and we have one over here. So this one is also using AN HM. So we'll use these 3 as our terms. And then we'll also do the reciprocals. So I guess what would probably lead you into using AMHM is noticing that each of these 3 terms is just a reciprocal of this. So now we'll have okay. And we already know that this is equal to 1. So that would be 3. So then we'll move over the 3. And since this is 3, A plus B over 2 plus C over 3 is more than or equal to 3 times 3, which is 9. So that is the answer. Okay, I have 2 more problems. Okay, I'll explain. For the first one, we're just going to use A1, A2, A3, and A4 as the terms. So yeah, let's make sure that they're squared. And then we want to have something over here to make it to where we have this. So it's pretty obvious that it's going to be 1 squared plus another 1 squared and 2 1. Okay, so that's what we have right now. So we know that this inside will be 1. So when you square it, it's still going to be equal to 1. So therefore, the minimum value of A1 squared, A2 squared, and A3 squared and A4 squared, it'll just be this. And then when we move this over to the other side, we will have this. One over, and this right here will just be 4. So the minimum value is 1/4. So I guess there's this thing called the lazy way, where if you really just choose each of the terms to be the same as each other, then you should achieve like a minimum or a maximum value. So it's not a very concrete answer, but basically, since all 4 of them add up to 1, if you make all of them 1/4, since they'll be equal to each other, you'll see that it'll just be 1/4 squared plus 1/4 squared, and then 4 of them. And that would still achieve 1/4. So if you ever feel like you just can't use a formula or it's not working out, you can just try the lazy way to work it out. Okay. I'll explain this one. So this one looks pretty complicated, especially since the coefficients really don't match up or they're not symmetric. But that's kind of a clue to use the Cauchy-Schwarz inequality. So we'll let A and B still be terms. And I'll have something here to make it to where we have this. So we should use this to find out that we need to use these. Okay. So, and then you just make sure and check that this is true according to Cauchy-Schwarz. So yeah, once we find out that that's true, we can divide both sides by a squared plus b squared to get okay. So this is what we're trying to find for a maximum value. And we can see that this is just 25. So the max value would just be 25. So I'm not exactly sure if the lazy way works out for this. So yeah, the lazy way doesn't work for this because it's a little more complicated when the coefficients are different. So let's do, I have 2 more problems and then we'll move on to breakout rooms. Okay, I am going to explain. So these problems are pretty similar, and they both use AMGM in a different way. So you don't just straight up, well, for the first one, you don't just straight up plug it in. So we have a squared plus 25 over 4a. So we can break this up to have this. And then once we simplify it, we'll have that. Now, this is when we use ANGN. So we'll use both of these as our two terms. So it'll be more than or equal to the geometric mean, which would be, okay, so this is probably the part where it ends up passing out. So it would be square root of 25 over 16, which is equal to 5 over 4. So the minimum value is 5 over 4. Okay. Now I'll do the second one. So find the minimum value of AB plus 2 over A plus 4 over B. So this one is honestly just AMGM. You don't even have to split anything up. So you just use them as your three terms, and you just multiply them. So we're going to have AB times 2 times 4 times that. And then these will cross out, and then this will be just 8. So 8 cubed is 2. So now we just carry over this denominator. And it'll be 3 times 2, which is 6. So the minimum value is 6. Okay. Okay. So Mr. Chen, since there's only 4 people, do we still need to break out into separate rooms? Mr. Chen?
All right, Chris. So you want to make a breakout room, right?
We only have 4 people, so I think we can just stay in this main room.
Okay. Okay. Just the main room. Okay. All right. Okay. Continue.
Okay, so I'll post the solutions in a few minutes after you guys look over the problems. So how are you guys doing with the first problem? You can unmute and just say what your thinking process is.
I got a 9 for the first problem.
Okay, let me go check the solution. Yep, it's 9. Do you want to share how you got that?
Okay, so basically due to AMGM inequality, x plus y plus z all over 3 is greater than or equal to the cube root of x by z. And we know that x by z is 27. So the cube root of 27 is 3. So x plus y plus z over 3 is greater than or equal to 3. And that means x plus y plus z is greater than or equal to 9.
Let me just write this out real quick. Okay. So yeah, for the first problem, it's just going to be the 3 of them using AMGM. It's going to be more than the cube root of this. And then they already gave you that this is 27. Well, yeah. So, and then you just move this over the denominator 3, multiply by 3, and that's why the answer is 9. I'd recommend doing number 4 next if you want to stay in the easy side. Once you get the answer, you can send it to me in chat, and I'll tell you if it's right or wrong. Does anyone have a thinking process? Or do you guys want to look at another problem? So we just have to manipulate this a little bit, and then the problem turns out to be pretty easy. So, yeah. So when we want to do AMGM, it's pretty obvious that once we multiply it, the A and the A minus 5 won't be able to cancel out. We won't be able to get basically a number. So we'll manipulate it and get it to where we have this. And then we'll add back the 5. So this won't change the equation eventually. So now we can treat this as one term and treat this as another term. And we'll be able to find the answer. So if we just set this basically aside using AMGM, we know that okay, so we can cancel this out. And this would just be the square root of 4, which is 2. So when we move this over, A minus 5 goes more than or equal to 4. So once we add in this 5, that means that we're more than or equal to 4 plus 5, which is equal to 9. So the minimum value is 9. Okay. You guys can look at number 5, I guess, next.
Yeah, for number 5, we can pretty much do the same thing. Like
Yep.
subtract B. And like use the MGM.
Yeah. So do you want to explain how you got it? And I'll try to write it down.
Okay, so the expression is equal to A plus B plus 1 over A minus B times B. And you have to add B, yeah. So then we can apply the AMGM inequality. So the arithmetic mean is just A plus 1 over A minus B times B over 2. And the geometric mean is just 1. because once you multiply all of it together, it's like it just cancels out.
So yeah, these will cancel out to get 1.
Yeah, and then you multiply by 3.
Yeah, the answer is 3. Okay. You guys can keep going. Okay. Maybe you guys can try number 2. It's a medium difficulty. Does anyone have a thinking process for number 2? So I think the first step when it comes to this would be to find a way to relate the 2 equations given. So we're trying to find the smallest value for this. And what they have for us is x plus 2y is equal to 1. So I think the easiest thing to do would be to use this one and basically substitute it in for both of the numerators. So this is what we would get. Okay. Then we should probably simplify it a little bit. And yeah. Okay. This is where we would apply AMGM. So yeah. We're going to ignore just this part for 1 second, the 3. So this is what we would have. This would be more than or equal to and then we can cancel out the xy. So it would be more than or just equal to root 2. And then we'll move the denominator over. So 2y over x plus x over y is more than or equal to 2 root 2. So now when we add, include the 3 again, we'll just add 3 to it. So the answer is this. This would be the smallest value possible. Okay, Tina has a good thinking process for problem 10, which is a challenging one. So do you want to explain your thinking process for number 10, Tina? Sorry, Tina, I can't hear you. Do you want me to explain it for you? You put your things in the chat. So
Can you hear me now?
oh yeah, right now I can. What?
Okay. So in the numerator, I noticed there was a 2x plus a negative 2x plus 2. So it looked a lot like the denominator.
Yep.
I manipulated just like that and broke the fraction into x squared over 2x minus 2 minus 1.
Yep.
From there, we know that x squared has to be a positive integer. Oh, I see. And 2x minus 2, because x is less than 1, it's going to be a negative integer. So if we keep x 0, then that's the maximum because it's 0 instead of a negative integer, because negative 1 is greater than a negative integer plus negative 1. So the answer is the one that says it has a maximum of -1.
Yep. So what you said is if it says that x must be less than 1 but greater than -4. So if we choose a negative number between 0 and -4, we're going to have some sort of negative number squared, and then there's going to be a negative number here, -2. So this would end up being a negative number because the top side would be positive, and then this part would be negative. So it wouldn't give a maximum number. So that's why she used x equals to 0. So that will be 0 over -2 minus 1. And that will have the maximum value of -1. So good job, Tina. That's a challenging one. Okay. I'll send in the solutions so you guys can look at them for around last 8 minutes, and then I'll set up a quizzes. Okay, I posted the solutions at the bottom of the questions. So do you guys have any questions about the solutions? Is there a particular question you guys want me to like elaborate on their solution? I will explain number 7 since it's a word problem. And it's sometimes a little bit hard to see why that has something to do with Cauchy-Schwarz or AMG. So Farmer Bob has 96 square inches of wrapping paper. Find the volume of the largest rectangular box you can wrap with the paper. So let's let the dimensions be X, Y, and Z. So when it says that he has that so many square inches of wrapping paper, that's pretty much the surface area. So we have 2 times xy plus xz plus yz is going to be equal to 96. So this is what we have. So now we want the volume. We're basically asking for xyz. So this kind of reminds me of what would be under the radical inside of the GM. So let's try using these 3 as 3 terms in the AMGM. So there are 3 terms, which is why we have this. Okay. And we know that, we know that this part, the numerator, is equal to 48. So we just plug that in, which is equal to 16. It's going to be the volume squared and then cubed. So all I have to do is cut 16 to the power of 3 and then square root it. And this is how we get xyz, or the volume, is going to be less than or equal to 64. So the largest rectangular box you can wrap with paper would have, the volume would be 64 inches cubed. So, do you guys have any questions? If not, I can go ahead and start the quizzes. You guys can just send it in the chat or the thumbs up. Okay. So I guess it's just Albert and Darwin. Okay, let me get it set up. Do you guys need any help joining it? Daman, do you need any help? Okay. So I'll just start right now. If I put the code and link in the chat, Darwin, so if you want to join in a little bit later, you can go ahead. There's only 11 questions. So. We got Albert. So I guess that's all for today. So I'll post the quizzes, the breakout room, the solutions, and the presentation in Discord later. So, thank you. Bye.
Thank you, Grace. We're good class. Thank you.
Yeah.
Bye-bye.